type digi, digital clock. Then I'm going to press Control and W again. Make sure you're in all groups, all families, otherwise you're limited to what comes up. I don't like the way that they name things on here, but you know, it could be worse. 3 flip-flops, then cancel. I'll zoom in, not Q, goes to D for each of them. And we know that with a ripple counter, not Q of the first flip-flop clocks the second one. Then I'll grab my clock, put it a bit closer. I'll make it say 100 Hertz. Not that that's that important. You could leave it at a kilohertz if I wanted to. And then the thing that's sort of you may not have done before, I haven't done much to be honest on this program, is when you click simulate, you go to instruments, and then you've got an oscilloscope or a 4-channel oscilloscope. So I'll click 4-channel, I'll put one of those in, and you need to, this is a trigger which would tell it when to simulate. For instance, if you've got a signal of interest, you can tell it to trigger from that. But we don't need that trigger. But what we do need to is to ground this pin. So I'll press Control and W again. Ground. Put that there. And now I'm interested in what's driving it. I'm interested in the pendulum or the clock. And I'm interested in my first flip-flop output. I'm interested in the second flip-flop output. And I'm interested in the third flip-flop output. But if I simulate this, all the traces will be the same color as what the wires are. So I'm going to right click the wire on channel A, and I'm going to do segment color. I'm going to do it yellow, then right click segment, going into channel B. I'm going to make it green, sort of following the snooker, that snooker loopy song, yellow, green, brown, blue. So I'll do a sort of browny color, not too dark, otherwise it won't show up. And then right click the final input, and I'll make it a nice light blue. So because I've done yellow, green, brown, blue, and I'm used to the order of those, I'll be able to tell which input's which when I look at the oscilloscope. So you press simulate or run, and nothing happens. So you click the oscilloscope, double click it, and now what we have is all 4 waveforms. But it's not very good having them all in the same position, because you can't tell when one's rising and one's falling. So what you need to do, you've got this channel selector switch, A, B, C, D. So channel A, I'm going to change its Y position. I'm going to move it up the Y axis. So on Y position here, I just click there, and I'm just going to click up. I'm going to put it there. And then I'm going to go to channel D, because I know that needs to go at the bottom. I'm going to do that right down near the bottom, maybe up a tiny bit, and then I'll go channel B and C. Well, I'm moving C down, so I'll go to C first, then I'll move it down with this little click button, and there we go. We've got a nice 3-bit ripple counter showing the clock at 100 Hertz. So you can see the time per division, 10 milliseconds per division. So at 100 Hertz, the period is 1 divided by 100, which is 10 milliseconds anyway. But if you wanted to, you can always click this and change it so you can see more or less of the counter on one screen. The only thing is it flickers, which is a bit of a pain, but if you increase the frequency, the flicker will be less pronounced. So I just wanted to show you how to do that, really. And then when I click stop or stop the run, it just disappears, and then, well, actually it stays there. That's a good point. If I press play and I want the whole screen, I can just wait till it gets near the end and then press stop. If I wanted a different amount of time on the x-axis per division, I could do that. And then you just stop or pause it at the right moment and you'll be able to see a nice binary count. So here's our clock, and at this point all 3 flip-flop outputs are low, so that's 0, 0, 0. Then it's 0, 0, 1, and then 0, 1, 0, 0, 1, 1, and then it's counting up in binary.